Let's say we're trying to differentiate the product of two functions. For example, maybe we're trying to differentiate x squared times sine of x. We can do that using the limit definition for the derivative. So it'll look something like this. We're taking the limit as h approaches 0 of what we're trying to differentiate, but nudged by a small amount h that's approaching 0. So k of x plus that nudge h, g of x plus h. And then just minus what we're trying to differentiate. K of x, g of x, all over h. From here, I'm going to add in a new term and subtract the same term. So in the end, they cancel each other out, but it'll help us simplify down this expression. So we'll have the limit as h approaches 0 of k of x plus h, g of x plus h. I'll start by subtracting the new term. It'll be k of x plus h, g of x. Then I'll add it, k of x plus h, g of x. So those two would cancel each other out. K of x, g of x, all over h. From here, I'm going to split apart this limit, and I'll do it just in half here. These first two terms in the numerator will go with the first half, and these two in the second. They'll both have the limit as h approaches 0. So it'll look something like this. The limit as h approaches 0 of the first part of the numerator here. And notice they both have a k of x plus h. I'm actually going to factor that out while we're at it. I'll put it right at the front, k of x plus h, and it'll be times what's left over, g of x plus h minus g of x. G of x plus h minus g of x all over h. So that's this first part here, and I just factored out that k of x plus h, put it at the front. We could see if we were to redistribute it, we'd end up with what we had here in the numerator. And this plus sign tells us we're going to be adding the second half. The limit as h approaches 0 of, again, I'm actually going to factor something out while we're at it, and this time it'll be this g of x. It's common on in both of those terms. So I'm going to put it right at the front, g of x times what's left over, k of x plus h minus k of x. K of x plus h minus k of x over h. And I guess I should end that big bracket here too. There we go. All right, we're almost done. I'm going to split apart this even further. And then this, I'm going to pull the g of x out to the front. Here, we're going to be splitting it up as k of x plus h with the limit as h approaches 0 times g of x plus h minus g of x over h with the limit being taken as well. I'm going to work up here now. So the limit as h approaches 0 of k of x plus h times the limit as h approaches 0 of g of x plus h minus g of x all over h. This is our first part here, and I split up the limit into this term times the rest. Now, before we work on the second part here, let's clean this up actually, because if we look at the definition of a derivative over here, notice it's the exact same as what we have here, just this being g of x. So this part is actually just g prime of x, the derivative of g of x. And of course that'll depend on what our function is. In this case, maybe with the example it was sine x, and differentiating it we'd get cos x. This first part here, k of x plus h as h approaches 0, there's nothing wrong with just plugging in 0 for h, and we'll see we'll get k of x plus 0, which is just k of x. So far, this is what we have. k of x times g prime of x. And that is what we got down here. K of x, g prime of x. All right, let's work on the second part. So I said we'd be pulling out the g of x to the front, so let's do that. G of x times, and we can do that because there's no h in it. We're not taking the limit anywhere in that term. Times the limit, as h approaches 0, of k of x plus h minus k of x all over h. And again, you might be noticing that's just our definition of a derivative. And this is, of course, with the function k. So this is a regular g of x times the derivative of k of x, just like that. And that was this second term here, plus, we still carry that down, g of x, k prime of x. All right. So what does this tell us? It means if we're trying to differentiate the product of two functions, we're first going to multiply one by the derivative of the other, and then we're going to add the other times the derivative of the first one, so that we're differentiating one in the first term and the other in the second term. Maybe that makes more sense. Back with this example here, that would mean we're going to use k of x for x squared, sine of x for g of x. We're doing the regular first one, x squared, times the derivative of the second, cos x. And we're going to add the regular second, sine x, times the derivative of x squared, 2x. And you could simplify that a little bit, but that would be how you use this formula. So hopefully this was useful, and have a great day.